What's up, dev team? Hope everybody's doing great. Hope everybody's doing well. My apologies for not posting anything for a while. I've just been going through some stuff and kind of wanted to take a breather, but it took a bit longer than what I wanted to. So I wanted to come back and do more videos, and I wanted to start this video off with going over something that everybody, or maybe a lot of people, might be familiar with in regards to, the game animation sample project, or maybe something you've seen in passing that you use in your own projects, regardless of if you're doing motion matching or state machines, which is the pose warping nodes. Stuff like orientation warping, stride warping, or slope warping, and maybe a few other, skeletal controls that you've probably, like I said, may have seen in passing, right? So, maybe for those that don't know, or, that are new to this, their Unreal Engine does provide cool nodes that allow you to do more, in a sense, like fluid animations or more dynamic things with your characters' animations, in a sense, right? So, as everybody can see, I do have the page on the Unreal Dev community forum for pose warping, because one of the things that I do want to go over and talk about with everybody that I've been playing around a lot with lately in my own projects, because that's another reason why I've been gone for a while, is because I've just been trying to work on my own project and also update my 5.4 to 5.5 and do a bunch of other stuff. But I had a lot of time to play around with orientation warping, as you can see here, right? So, when we look over what pose warping does, is that it lets you dynamically adjust a character's animated pose to align with the capsule movement. And, this document's going to go over those different tools, right? So, let's go ahead and drop down to kind of how it looks, right? So as you can see right here with the pose warping overview, you can already see like the character, that the example that they give, where the character looks pretty fluid, right? You would almost think like they have, their own, they pretty much do have their own animations, but you'd feel like that these are custom tailored animations to where they're getting such fluid movements and other stuff. Well, believe it or not, what they're actually using is a lot of like very basic animations that you might see like on the market, or maybe something very basic that epicgames have made themselves just to showcase for this demo, or it could be like the old third-person template, or maybe some form that they're using, right? Well, in this showcase that they're doing, they're using orientation warping, stride warping, and slope warping, as you could tell by like how the feet look, how the character's orienting their waist and legs and other stuff like that, right? And also their strides, to match like the speeds that they're going at. So, however, for this video specifically, we're going to take a look at what they're doing right here with orientation warping right here at the pelvis. So I'm going to drop down to orientation warping, and we're going to go over that, and we're going to go over how you can get that set up in your own project, and we're going to go over how you can get it set up for state machines, as well as getting it set up for motion matching. And I'm going to show you my examples that I have, as well as more of a notable example from the game animation sample project. So, as you can see right here with orientation warping, that the orientation warping node applies directional compensation warps to animations in motion. With this node, you can isolate and warp the leg IK bones of an animated pose to align with the dynamically updating locomotion direction of the root motion. The pose will also maintain the facing angle by twisting the spine bones along a designated axis. So this feature can be used to fill coverage gaps in animation sequences, reducing the need to manually create intersituation or institutional animations, or the creation of excess blend space transitions. So a lot of times what you'll probably see people have in their projects, or maybe have worked with others, or maybe discussed with others in their projects, but a lot of times with like blend spaces, right? A lot of times you want like an 8-way locomotion system up for the animation or the blend space, where you have like your character going forward or diagonally left at 45 degrees, or diagonally right at 45 degrees, or left and right, or back left for -45, or 135, or the other way 135 or 180, right? However, you mostly utilize the blend spaces or whatever to help with strafing movements, because if you do orienting to movement type animations, that you're always going to be facing wherever you plan on moving your character. So it's unnecessary to do a blend space in that aspect since you're always going forward. But however, with strafing, that's when it becomes a different story, where most of the times, especially if you're new to a project, you'll probably learn how to create blend spaces to help blend your character to move at, left, right, diagonally, backward, whatever, while the character is facing forward. So you'll create that 8-way locomotion to fill or cover those gaps in where your character will be moving around and it blends properly. Well, orientation warping can also be used to cover those gaps that you may be missing, especially it can be used to enhance your blend space that you have created, or even with a motion matching system that you probably set up where you have like maybe 8 different locomotion animations to choose from, and depending on what direction you're going in, that will be picked out, and orientation warping enhances that by making sure that there's proper coverage when it goes into the next animation sequence, depending on what movement or direction you're going in. So to take a look at some of the properties that we will be mostly looking at as far as the orientation warping is concerned, is we have our orientation angle, which we won't be messing around with because we're going to be switching our evaluation mode to graph, and I am going to walk through how to do that. But basically what orientation angle is you have to make sure that evaluation is set to manual, and it defines the degree of orientation you want to warp the locomotion component's pose. And the value is relative to the axis specified under the rotation axis property. So this pretty much is similar to locomotion angle, but it handles direction a bit differently. And I haven't got to mess around with it too much to fully and completely understand what it's doing as to where I know what the locomotion angle is doing because of how I have messed around with it. So with the locomotion angle, as you can see, we need to set the evaluation mode to graph, and then it will we use it to define the degree of orientation you want to warp the locomotion component's pose. And what this also does is it's built to use graph-driven values, and what this part means is that data, when you look at your pipeline, right? So let me pull up a project that I have to the side real quick. You'll see right here these lines, these colored lines. This is a pipeline that your Anim graph uses to move or flow data into the next node, and the next node will then process that data amongst whatever else it has within that node, right? So in here you can see that this is a cached pose locomotion, which is then being fed into here, and then going into another cache pose that I have here because I do have some stuff underneath that I don't want to spoil because it does involve orientation warping that I want to look over with y'all in a bit. But this is the event data-driven values that are being passed into the next node. And so this is what in graph mode that the orientation warping will consume and read from in order to be able to then update itself and those values and play out animations properly. So the next thing we want to look at is location angle delta threshold, which this specifies the angle threshold to prevent erroneous over-rotation of the character. By default, this property is set to 90 degrees, and it can be disabled by setting a value to 0. So this may sound confusing and may sound like something you won't touch, but this is actually very important depending on your animations. Because this determines the degree and how the character angles their lower half when playing out their locomotion, right? So when you have all your strafing movements, right, you have your back left, backward, and back right, or side to side, front left, front right, forward, then, depending on the degrees you set, the orientation warping will kick in to help with the correction of the blendings, more so for the backwards movements of your strafe. So at 90 degrees, what it'll then do is it'll recorrect itself to then, counter rotate or counter angle it. So that way it then fixes the feet or leg positioning into a proper direction or pose, and that's something we will be going over so you can see how it looks when we mess with the delta threshold. So then next is the spine bones, where we're going to define the spines that we're going to be tampering with, and orientation warping will adjust or, rotate amongst, right? So normally with the spine bones, you want to do the entire spine unless you have something very specific that you need to set. You can't set all the spines for, but typically by default, you would just do all the spine bones for the values. Then we have the IK foot bones, which, we define the indexed instances of the IK foot bones. So basically like your IK foot Rs, or for inverse kinetics and stuff like that, so it knows how to properly move your legs and stuff like that. And then rotation axis is what we define the axis by which the orientation warping should occur. So you'll see Z axis, and what this rotation is doing is basically warping our character around the yaw. So when you see the Z, it doesn't mean like up and down movement. It means like rotation, around the Z axis of your character. So your yaw, basically. And then we have the distributed bone orientation alpha. We really won't be messing with this, but basically what it does is specifies how much of a rotation is distributed across the character's body through the spine bones. This value is biased towards the upper body, with a value of 1 indicating the total rotation occurs at the index 0 spine bone, and a value of 0 indicating rotation occurs amongst the highest value. So basically, and you'll see when we actually mess with the node that it's going to be set to 0.5 because we want it at the midway point, which is perfectly fine. So like, unless you have something very specific as far as upper body animations that you want to play out, or lower body you want to play out, you would either set it to 0, or I'm sorry, a 1 to get the first spine bone, or a value of 0 to get the last spine bone, or the highest up bone. And then lastly, we have rotation interp speed, which specifies the interpolation or blending speed in alpha per second in order to reach the final warped rotation angle. Lower values indicate low interpolation speed and thus slow transitions between locomotion changes and animation warping. Greater values have greater transitions with less smoothing. A value of 0 will cause instantaneous rotation. So you'll see this when we play around with the node, because we really won't be touching it because the value that it's at is perfectly fine. But basically, greater values will have quicker transitions with less smoothing, and then 0 will be instantaneous because it's disabled. So the lower you have it, will slow the transitions. The higher you have it, the faster it'll transition, and 0 just completely disables it. So, enough talk about that. Let's go ahead and get into playing with it. So I'm going to move that over. And what we're going to do is you're going to open up a new project, or maybe you already have a project that you have open that you want to incorporate this in, whichever is fine. But for this demonstration, I do have the third person template up because I want to start from scratch and showing you how a lot of this stuff is working. So what we're going to do first is we have to enable a plugin in order to get that skeletal control, because to show you what I mean by that is if you go into characters, mannequins, animations, and then you're going to open up your animation blueprint. So in this case for, the third person template, it's going to be Manny. When I open that up, I'm going to go into the Anim graph, and within the Anim graph, here we go, we have our basic animation nodes. But as you can see in here, if we look for orientation warping, you can see that we do not have it by default, and it's under skeletal controls. But for us to enable skeletal controls, the plugin that we need to grab is animation warping. So if you've messed around with the Game Animation Sample Project, they have this already enabled for you, but maybe for your projects you probably already have it too. But basically what animation warping does is it provides the framework for animation and pose warping. So as you can see, this plugin includes stride warping, orientation warping, and slope warping alongside the root motion delta animation attributes. So we get like root motion stuff. So go ahead, and once you have that typed up, go ahead and select that, and we're going to hit restart. So I'm going to go ahead and restart, and I will see you when my game is back up. Welcome back, dev team. So my game is finally reloaded. So let's go ahead, and I'm going to close out of that, and let's go ahead and I'm going to reopen my ABP Manny, and let's dock that there. So we're going to keep the basic things that is set in here because we don't need to change anything, but we do need to actually add something. because this is actually going to be important for later when we do orientation warping. And also too, you know, if you're using blend spaces, you probably already have this set, but for orientation warping, you know, this is also very important. So go ahead and scroll down to, you know, past the is falling set right here. And what we want to do is we want to right click, and I'm going to grab a property access node because I want direct calls to variables that I want specifically. So I'm going to grab one. The other one that we need, we already have set, which is the velocity. So what we're going to do is, since the velocity is already set, we're going to go into our variables, and we're going to go to essential movement data, and I'm going to click and drag out my velocity, and I'm going to hit get, so that way I get the get nodes, so that way I can get the information that's being passed through here for our current velocity. Then with my property access node, I want to do a direct call because I don't want to make a variable for it or anything like that. I don't want to do all that extra stuff. I just want a direct thread safe call to the actor rotation. So off of here, what I want to do is I want to go down to character component, or at least character. I gotta, if in case you encounter those weird blocks as far as the property access bindings, you just need to move your event graph up a little bit in order to access them. But now you can see I can finally access my stuff. So what we want to do is we want to go to character. And then what off of character, we want to do, where is it? It should be get right here, get actor rotation. And I want to directly call that. So, you know, the benefit with a property access node is that I get to do direct calls to whatever information that I want. And so as long as that character is using it and it's constantly being updated and it's on time, this will always be accurate. It's going to be thread safe, where it doesn't use like a game thread and does these calculations to the side. So it's more performant, more optimized in doing that. But you got to be careful as far as having too much, and also you got to make sure to be careful of your game's play speed, because in case anything ever gets offset or stutters or breaks somewhere, this could lose the call, and in which case everything else could probably start breaking along with that until everything catches back up again. So, but other than that, we don't really have to worry about it with a basic project. It's just you want to worry about that more when your game gets bigger. But for the moment, we are fine, and it is fine to have a lot of property access nodes. Just keep some things in mind. But off of the velocity, what we want to do is we want to drag off, and we want to get the calculate direction. And we want to plug the actor rotation in here. So what this is doing, as you can see, is it returns the degree of angle between velocity and rotation forward vector. So what this is basically doing is, so we're grabbing our velocity, and what the velocity is doing is it provides us information about our character's speed in whatever direction we're going in, right? So say I'm going 50 miles per hour north, then my velocity is 50 miles per hour northward. So my character is facing north, I'm going 50 miles per hour north. That is my velocity. So it's basically a speed with a given direction, and that's what makes up our vector point or our velocity. And then what the actor's rotation is doing is it's getting where our actor is currently, how it's currently rotated and where he's facing, right? So if I were to get actor rotation by itself and start doing print strings, so just to, you know, to show y'all, I'm going to go ahead and drag off create a new pen, and I'm going to drag off and do a print string. So as far as this goes, let me copy that and paste it over here. And I'm going to compile and save. As you can see, when we start playing, our character's actor rotation, it's at 0. And no matter how I move around the mouse, it is not going to change. It is only when we start moving the character that you can see that our yaw is changing. So basically our rotation around the Z. And so that is what we're trying to account for, is where the character is moving in, and then in what direction, and then we calculate both of those using complex math that's within that pre-built function that epicgames provide us to then get us a direction that we're going into, and it's primarily used when strafing. So that's why this is important. So it basically calculates what it needs to in between these to then output a directional number, right? So what we're going to do is, now that we've looked over that, let's go ahead and I'm going to right click off of return value for calculate direction, and I'm going to promote it to a variable and call it direction, because we're going to want to call this in our orientation warping, so that way it knows what direction we're going in order to, you know, assist us with the coverage of our character's movement. So once you have that, go ahead and drag it into the movement data, so that way it's just there, so that way when you close it, it's just clean. But other than that, what we're going to do is I'm going to keep that so I can show you what it is doing. So let's create a new pin, and I'm going to drop this down, and I'm going off the third pin. I'm going to drag and prettify that real quick. But now we have our direction constantly being updated. So now to show you what the direction is doing, I'm going to drag this out and do a get, and I'm going to plug it into the string. And then I'm going to compile and save. So every time this direction updates, we then also pass that value into our print string, so that way we can see what's going on. So as you can see right now, we currently have 0, and if we go forward, it is 0. But then we turn, you'll notice how we have a shift of numbers, and then it reorientates back down to 0, or like readjusts back down to 0. Because what it is doing is it is trying to calculate the direction that we are moving into before it resets back to a forward-facing direction. Because if you recall off the calculate direction, off the rotation forward vector. So it's constantly doing comparisons against our character's forward rotation. So basically, when you look in front of the character, it's going to be just a smidge ahead of the character that it is accounting for. So when we move in that forward direction, it is always going to return to 0 as a positive, because, you know, we're always going forward wherever we move our controls to. Like if I hit WASD, we are always going to reorient to movement. However, let's go ahead and set up our strafe functionality now, and that way you can see how the direction is now going to be calculated when we strafe. So go ahead and open up your content drawer, and let's go ahead and go back to content, and then go into third person, then blueprints, and then open up the third person character template that we have here. So I'm going to use a debug key for this, but you'll probably have seen in the game animation sample project, or maybe in a project that you're doing, is that you have maybe a strafing button, but primarily in the game animation sample project, they use the middle mouse button to toggle strafing and orienting to movement. And so that's what I'm going to be simulating with this debug key. So off the debug key, what we're going to do is I'm going to create a new variable for us to toggle. This does not do anything. So for those that do not understand what we're doing, we're going to be creating a Boolean. And what a Boolean is doing is we're just trying to set true or false conditions to tell our other functionality, or the other parts that we're working with, you know, that this is true, trigger this functionality. This is false, trigger this functionality. So that's what we are doing here for those that do not know. So what we're going to go ahead and do is, since we have a new variable that we are creating, we're going to leave it as Boolean, because that way we can set our true and false value. And then we're going to call this wants to strafe. You can also do it another way too. It doesn't have to be called wants to strafe. I'm just trying to tell us, or tell the character, that they want to strafe. You could do it another way too and just call it is strafing ? You know, it doesn't have to necessarily be, you know, either one. You can call it whatever you want to, you know, remind yourself that, hey, strafing functionality is happening when this triggers, right? So you can call it is strafing ? Wants to strafe, is going to strafe, is gonna strafe, stuff like that. But for the moment, I want to keep it, you know, neat and clean to how Game Animation Sample Project, you know, does their strafing, and we're going to call it wants to strafe, because we want to tell basically our character that yes, you want to strafe. However, there's a little bit of nuance to this, because what we have to do is when we press this, we want to toggle this. However, with a middle mouse button press, you can see that we don't have any action values here to be able to trigger a true or false when we press. So what we have to do is we want to grab another wants to strafe. We want to do a get. And what we want to do is basically drag off of here and get a not Boolean, Because what this not boolean is doing is whatever this is set to at the time that this is pressed, it is going to inverse the value and set it into here. So at the time of this button press, when I press it, if this is false, it will then be converted here into true and then set this to true. But then when I press this again, if this is true at the time that I press this, it is going to then change into false here and then set it to false. So that's what we are trying to do here. So now we have the basic strafe set up here. So I'm going to comment that and call it our strafe input. So that way we know what it's doing. And then what I'm going to do is now we have to provide some functionality. And so what I'm going to do is I'm going to grab an event tick, because on every frame of our game, what I want to do and make sure of is that our rotation is properly aligned to what we are trying to accomplish here, right? So if I press this, I want to be able to strafe, and I want to make sure we maintain these strafing. But then if I press this again, I want it to set it to orient to movement and ensure that we maintain orient to movement until otherwise, done. Another way you could do it is by setting a branch here, but I want to make sure on continuous tick that our movement is proper, right? So what we're going to do now is on our functions over on the left side, we're going to create a new function, and I'm going to call it update rotation, because you can use this to, do great many things in regards to rotation, but also too, I'm trying to keep everything organized and contained by creating a function, just like how they do it in the game animation sample project. So off of update rotation, what I'm going to do is grab a sequence node. You definitely don't have to do this, but I do this in case there's other functionality that I want to put in to where I can just add pins, in case there's something more I want to do with the update rotation. But at the moment, we don't really need this for the sake of this tutorial, but later if your project, gets bigger, improves, whatever, that you may want to start using sequences within your functions. So within this, what we're going to do is we're going to create a branch. So I'm going to hold B and left click to create a branch, and I'm going to then connect the first sequence pin into the branch. Then I'm going to come down to the variable that I had created, and I'm going to drag it out and do a get. So basically, whenever we press that button to then toggle our strafe out here, once it updates, we want to retrieve it here and pass it in as the condition to where if this is true, play out true. If this is false, play out the false. And so what we want to do is, if we want to strafe, we want our true to be set to our strafing movement off of our character movement. But then if false, if we don't want to strafe, then we want to set it to orienting to movement. So go ahead and off of your components, drag out your character movement, and off of your character movement, you're going to drag in and look for controller desired rotation, and we want to do a set, use controller desired rotation. And this is what is responsible for the strafing, where basically when this is toggled on and our orient to movement is toggled off, this in turn with that will then cause us to strafe. So go ahead and grab another character movement node, and off of that you're going to look for orient to movement, just like so, and you're going to grab a set and you're going to place that above there and then connect the two. So like I said, what we want to do is we want to use this because this is actually what's responsible to allow us to strafe, but we also have to make sure that this is toggled off, because these do conflict with each other if they are both toggled on. So with toggling this on and then toggling this off, we then achieve strafing movement. But what we also want to do is we want to copy this and then paste it, because when we toggle this to false, that we can then go back to orienting to movement. So go ahead and off the first set, we want to check off this to make sure that this is set to true. And then we're going to leave this as false because we don't want to orient to movement if we're strafing. And then when we don't want to strafe anymore, we want to then toggle it off and then toggle this back on. Then once you do that, go ahead and connect both of those, and now you have your strafing functionality set. However, there is one last thing that we need to do before our strafing kicks in. And just to show you what I mean, you'll see that our wants to strafe boolean that we had created, our default value is false. So if I go ahead and hit play, you'll notice that we can still orient to movement, right? Because we haven't, if you want to start off the game strafing, you have to then set that to true, because if we don't, then we just start the game off orienting to movement. However, if I do click my middle mouse button, it is not toggling off for some reason. Did I connect it wrong? Oh yeah, I didn't connect it. So here's another thing too, another mistake I made. We do need to then grab our update rotation and then connect it to our event ticks. That way it properly updates our rotation. So go ahead and do that, and then compile and save, and then take a look at it, right? So as you can see, we can still orient to movement, but then as you can see, when I hit the left of the middle mouse button, we are now strafing. But then when I toggle it off, we are no longer strafing and we're orienting to movement. So if you want to start the game strafing, all you have to do is just click on your wants to strafe, and then check that, and then compile and save, and then you will see that we start the game strafing. Now, we still have our direction hooked up in our animation blueprint, as you can see with the print line that we have spewing out on our left side, right? Now that we have strafing enabled, watch what happens when I actually start moving around while strafing. You can see that numbers are actually being generated because it's showing where we're going with our character's rotation facing forward. So as you can see that when I go left, we get a -90. When I go forward, we get 0. When I go backward, we get 180. And when I go right, we get 90. So it's returning us our degrees of movement, or our direction, basically, depending on where we're going while strafing. So that way it lets the game know, like, hey, what angle should we technically be at if our character was like forward facing, you know, whatever, right? So now that we have that set though, we can go ahead and go back into here, and I'm going to go ahead and delete the print string now that we see how that works. So now we have the basic direction set up and strafing set up. Now we can actually go ahead and take a look at orientation warping to see how it actually plays out and get to the good stuff. So what we're going to go ahead and do, or at least what I'm going to go ahead and do, just that way we can play around with this and make sure everything's good, is I'm going to actually move this locomotion up, and then I'm going to disconnect from main states and the default slot. And what I'm going to do is I'm going to drag the default slot down just a tad or a hair, whatever. And then off of the main states, I'm going to drag off and do a cache pose. Because what I want to do is I want everything to pass through here, our pose warping stuff to pass through here, and then pass into the rest of our stuff. So I'm going to call this post pose warping, just like so, because what I want to do is we're going to feed our locomotion into this cache pose, to where this cache pose in the main states is being called here, you know, to do our jumping stuff. And then when it comes back out, we will then do the orientation warping and other stuff when I do the other videos, and then exit into our post pose warp. And then we can call that post pose warp down here to then pass the data along to the rest of our animation blueprint. So now that we got that set up, we can go ahead and do this, so that way I can then just play around with this section and not have to worry about anything. So let's go ahead and search for orientation warping, as we should have that now with our animation warping, and you can see that we've been added skeletal controls, and you can now see that orientation warping is available. So I am playing around in Unreal Engine 5.5. I believe this node was introduced in 5.2 or 5.3, and it's had considerable updates. But if you are on an older version of Unreal Engine, there may be some stuff you're missing, or maybe does not show up right away just like this, in which case you would then have to scroll down in the settings and toggle them here and stuff like that. But in the off chance, just be aware that if you do not see those, it's because I am in the latest version. So After that, let's go ahead and mess around with the orientation warping and actually get into the good stuff of what this does. So I'm going to compile and save just so we can get a reminder of how our character looks, right? So right off the bat, as you can see with how we're moving our character is currently strafing, and with its forward movement, you can see that when we go in diagonal angles or to the left, backward, to the right, left, right, whatever, that it only maintains forward-facing movement with the legs. A lot of people, what they'll end up doing, especially me, I'll always do it just because as you get better, you tend to find better animations, or you may be playing around with gameanimationsampleproject, whatever you may be doing, but you will always look for 8-way locomotion to where your character's legs will then line up properly with how the animations are supposed to look or play out, stuff like that. So right off the gate, what we're going to do is we're going to change the mode from manual to graph, because what we want is the data that's being passed down the pipeline to be fed into here and then taken care of with whatever we set here and then pass through. In manual mode, there's a lot of stuff that you would have to set up, as well as maybe some of the experimental stuff where orientation angle, whatever. But with the graph, we get a little bit more to it, but it's a lot better stuff in my opinion, or at least handles things nicely depending on how you set it up, especially with using the graph evaluation mode, which is what we're going to use. So go ahead, and what we're going to do is we're going to connect our main state to our orientation warping and our orientation warping to our pose. And what we're doing is we're going from a local space to a component space to play out the animation warping, and then we transition back from a component space to a local space or world space and then feed outward. So this is handling specifically the component, which would be our spines and other stuff of our character. So before we get into this other stuff, let's go ahead and set up the main settings that you will be needing. So in the spine bones, go ahead and you're going to add 5 array elements, because what we're going to be doing now is indexing or adding all 5 of our spine bones, so that way it knows to play out the animation warping or coverage amongst every spine bone. So like I said earlier in the video, if you have something specific that you're doing, you may not want all 5 of these, but for the moment, for a lot of human interaction or like animation, stuff like that, you will most likely end up doing all 5 spine bones. So with that being done, let's go ahead and get our IK foot root, which is pretty simple. We just type in IK and then grab the foot root, so that way it knows where the foot root is in relation to the feet and the spine, so it knows how to orient and warp our character when moving. So next we have to now find the IK foot bones, which is the left and the right. So go ahead and look for IK again, and we're going to get the foot left, and then we're going to do IK again and get the foot right. So now we have all the main data that we need for this to play out. So without doing anything further, if we hit compile and save and we play out, nothing should really happen because we don't have a bunch of other stuff set. So just because you set orientation warping does not mean it just automatically starts working. There's other stuff that needs to happen. One example that needs to happen is we need to tamper with our animation sequences. So with orientation warping or animation warping in general, your animations do need to have root motion set, so in order for them to work properly. So what we're going to go ahead and do is we're going to then go into our content, characters folder, mannequins, animations, and what I'm going to do is I already have a filter out, but if you don't have a filter, you're going to just click this right here to open it up, and you're going to want to go to animation and look for animation sequence, so that way we can filter out for just animation sequences. So I don't know why I decided to now just save and skin my character. Okay, cool. So what we're going to go ahead and do is, since we have all the animation sequences right in front of us, because we're on the top of a folder that has all of them, we're going to select all of them, and we're going to right click, and we're going to go to asset actions, and we're going to do an edit selection in property matrix. So here what we're going to be doing is you're going to select all of them because we want to modify them all at once. And so once you have all of those selected, you're going to go down in the settings and you're going to look for the root motion section, and you're going to toggle enable root motion for this. And what we also want to do is make sure that everything has force root lock, because we want to lock all the animations to the root when playing them out, and then have these enabled for our animation warpings and other stuff playing out. So once you have that, go ahead and hit save, and you're going to close out of that now, and let's go back into our ABP Mani. So again, just because we set that up, it should still not work. As you can see, yeah, it still does not work because we still have to set up other stuff. So now the first thing that we want to do is let's go back up to evaluation mode, and we're going to go and look at the locomotion angle. So for this locomotion angle, that's why we set up direction earlier, because this is what it takes. Because as you read through it, you'll see, you know, the character locomotion angle in degrees relative to the specified rotation axis. So as you saw with our direction when we did a print string, it was returning angle degrees of our rotation where we are moving in with our character forward facing. So it was returning angles. So think about it like this, right? So let me open up Paints, that way you can understand better as far as what I'm doing, right? So let's just pretend that we have a top-down view of our character. So there's a character's head with shoulder, you know, whatever, right? So when we do the rotation axis, or when we do the calculate direction, what it's trying to do with the actor rotation is it basically does like a notch in front to then tell itself like, hey, we're getting on the rotation axis, we're getting that forward vector of the character. So if the character moves left, as you can see, we then make a 90-degree angle, and that's why it returned 90 degrees, but that's why it returned it negative, because this is a negative axis. Likewise, if we go right, it then does 90 degrees positive. But then if we go backward, it is negative 180, because we're moving down on the Y basically, or since we're top, we're moving backward, or at least, yeah, this is X and this is Y, but we're getting 180 degrees. So that's why we were able to get that, and this is what it's getting for the locomotion angle. So likewise, if we went diagonal, you can see that we then have like an obtuse angle from our forward vector, and then this would spawn in, you know, negative 135. You know, this one would be positive 135, and then, you know, going in this direction 45, and then the other way negative 45. So that's essentially what it is grabbing, is these angles. So going back into the anim graph though, with our orientation warping, we want to set this, our pen, to the direction that we had set to grab those angles, those locomotion angles. So now if we hit compile and save, I believe it shouldn't still play out yet, or actually it does play out. As you can see now, our character is now orienting to our movement with its legs while maintaining a forward vector on the upper body. So as you can see, without getting any other animations whatsoever, we are now able to create somewhat of a 8-way locomotion direction for our character. So now the next thing that we need to assist with its coverage is we need to get the locomotion direction, which is the movement direction vector in the world space. So without going any further into it, what we need to do is return a vector value, and we want to grab our velocity, because velocity is an important vector value, because like I mentioned earlier in this video, is that velocity is your speed in a given direction. So if I'm going, again, 50 miles per hour north, then my direction that it's grabbing from the velocity or from my vector is north. Or if I'm going, 50 miles per hour left or east, then my direction that it's grabbing from the vector is east or left. So that's important. So This also helps with the coverage even more, so that way it's a bit more fluid, because now it's getting our rotation angle from the actor rotation and then also the direction that we're going via the velocity. So it helps smoothen things out. Then the next part is the minimum root motion speed threshold, and this is basically a value that we want to set to activate orientation warping, and it's set to 10 because we want it to say like, hey, you know, when our speed that we grab from the locomotion direction, our velocity is, you know, greater than 10, you know, then activate orientation warping. So you can set this to much higher if you notice certain things that are a little bit off or whatever, but 10 is pretty much fine for a default value that is provided. And then next we have the locomotion angle delta threshold. And again, when we looked at this earlier, it is a threshold to prevent erroneous over-rotation of the character, disabled with a value of 0. So to show you what this is doing, right? So basically it corrects or helps with our character's direction and mostly in backward movement. So if I go down to, where is it at? Right here, the debug, and I enabled the debug draw, right? The one thing that I want you to pay attention to is, like, we have a red line now to showcase our movement, but let me go ahead and click out of that just to show you. What we actually want to look for is, I believe it's our target orientation angle or our locomotion angle. It's one of these two, but we want to look at the angle when we're moving and showing you how it corrects itself, right? So if we go forward, you could see that we're like zeros pretty much all around the board. If we go backward, you can see our locomotion angle is -180, but then it corrects everything else to be 0, because what it's doing is it's overcorrecting basically to revert us back to like a forward facing position with our legs essentially. So if I go left, you could see that it goes -90 in the other angles. If I go right, we go +90 on those angles, but then watch what happens when I go, you know, left and like back left, right? You can see that our legs, we are now moonwalking backwards. So just to show you again, if I move back left, we are moonwalking backwards, but notice the angle of our legs. You'll notice that it's mimicking this movement, but going backwards. So see if I do it again, it is basically simulating like we recorrected back to going front right. So likewise, if I go back right, that we moonwalk back right, but then it simulates this motion because it corrects us back to like the front facing angle. So basically, this is a threshold to correct how where our legs are facing essentially when we're moving. Because watch what happens if I change this to 135, and this is done within the game animation sample project. So if I hit compile and save, watch what happens with the debug now, right? So if I go back left, you can see that our legs actually now allow us to go or strafe back left or back right, and it's due to the threshold that we've set because we've set it higher. Because watch what happens if I go backward first and then go left or right. So if I go backward and then right, it's going to moonwalk, or maybe I shouldn't have done it there because walls do overcorrect. But if I go back left, you will see that eventually we overcorrect, because what it does is with our angles, when we move back, it slowly corrects until it counter corrects because we've reached a threshold. Because you'll notice the numbers, like if you pay attention to the debug numbers, how slowly, just before it gets to the target angle that we are trying to get it at, that we moonwalk until it reaches that point and then overcorrects to meet that threshold. So likewise, if I set this to maybe like, let's say 165, right? And I hit that, if I go backward and left first, you can see that immediately right off the gate, like we've hit our threshold point going backward and it overcorrected to then get our backward strafing motion. So as you can see, we've basically now have our 8-way locomotion with just orientation warping. However, our character is still forward facing. So that's why this is really important. So, you know, maybe I might keep this on 165 for further stuff. Then lastly, we have in the evaluations, we have warping space. So as far as warping space is concerned, is that, let me pull up my notes for this one because it doesn't pop up when you have it hovered over like this. So as far as warping space, let me find my notes for it so I don't confuse y'all. Here we go. Defines the coordinate space for warping, and you can see how it defaults to the component transform because we want to apply to the characters like within its capsule components transform, right? However, when you click on it, you can also set it to the root bone transform. So as you can see, is apply warping relative to previous frames root bone transform. You want to use this mode when using an offset root bone node, which allows the root bone and component transforms to differ. So this is within the capsule component, or basically the character's current transform, and this is utilized more when you use the offset root bone node within the event graph. So you'll definitely have seen it in the game animation sample project. And what the offset root bone does is it basically allows your character's capsule component to drift a little away from your character in order to provide realistic simulations and other stuff of animations. And then when you do certain actions, you want to then have different techniques set to allow the animations or the character's root motion to then catch up with the capsule component and reset essentially. So for this, since we aren't going to be putting an offset root bone node up, we're going to keep it at component transform to keep it within the character's current component transform. So then this other stuff, as you can see, we went over rotation, interp speed, and as we said, like the lower the value, the slower and smoother the interp will be, but the higher the value, the more the rotation, interp speed, how the fast the character will rotate, and how unsmooth, uncouth it is. But then if we set it to 0, it will disable this, causing instantaneous rotation. Keeping it at 10 is fine, but stuff like 15, 20 works just as well, but just know that it's going to be greater. So I would probably set it to anywhere around like 5 to 8 probably for much smoother rotations maybe. And then this is the counter compensate interp speed, where it's the same as the rotation interp speed, but for counter compensate smoothing. And so 0 basically, again, it like disables it, so we're getting like smooth sample raw motion data. So what this is doing is it's a speed to counter and prevent over or rotation. So like remember what we did with this, right? So if I set it back to 135, how when we go back or backward forward, that's the counter compensate that it's doing. So it compensates us back to the movement that we actually want. So right there, because when it hit that angle just right, that we counter compensate, or at least that's the interp. It's mostly happening like right here, but that counter compensate is basically like how quick we want to rotate or make the adjustments for the excessive rotation. And then we have the max correction degrees. What this is doing is, it's allowed to do per second corrections using interpolation, and this minimizes pops when we have large difference between current and target orientation. So all this is doing is it's just correcting your unnatural body twisting, and the max that we allow it is 180, which when using direction, if we go backward, it's going to be at 180, but that's only if we had it set, to this to like 180 or other stuff. So it kind of prevents like the over rotation and stuff like that to keep us looking more natural. And then we have the counter compensate interpolation by root motion. And that's just to, determines whether to adjust or counter compensate the rotation speed, based on our root motion. And so we definitely want this to be true, so that way it can counter compensate, interpolate nicely, and correct our character without all the pops and other stuff, right? So that is pretty much it as far as what we want to mess with, because now we're going to be getting into the experimental parts with target time, current anim asset, and current anim asset time. This stuff you won't really be using because this is more of a manual setup, and there's no reason to really touch this. You can break a lot of stuff doing it unless you really know what you're doing. So we're going to leave these alone, and we're going to mess with these. So for the current anim asset, you'll notice that it's what this wants essentially is if we click on the select asset, that it wants strictly our characters either their pose asset or their animation sequence. But what we want to do here for the current anim asset is we want to actually pass in animation sequences, but we want to do this dynamically. So in order to do that, you'll probably have seen in the game animation sample project where within their motion matching node that they have set up, you know, just to pull it over to show you, because this is going to be an example that I was going to show eventually, is when I pull that over, as you can see, we are within the motion matching node because you have the orientation warping, you have steering, and a bunch of other stuff. But you'll see right here where they're getting an anim node reference, and then from that anim node reference, they're getting the current blend stack anim asset, and then the asset time, or the play rate of that anim asset. And that is being called through here, the locum blend stack input, and that's because it's a tag, and that's how you reference a node within the animation blueprint. So what this is doing is when an animation sequence is plopped into here to then pass down the pipeline to, you know, feed data into, adjust, do whatever with, it will capture that anim sequence or that asset within here, and then once it does, it's going to then pass into here to where we can get what the animation that is currently being played, as well as the play rate of that animation, in order to pass into the animation warping, so that a way it knows what animation is playing, the time that it's playing at, and be able to correct or cover, you know, the gaps of that animation and so on and so forth. So that's what that is doing. However, those two nodes are specific to motion matching. So unless you're within the motion matching node, you are not going to get those, because if I tried it right now, or, you know, current, you're going to get a bunch of other stuff like get current animation time, notify state, time ratio, like whatever, but there's no blend stack anim asset. So for example, let's go ahead and make a tag, because we do need a node reference, right? Because what we're doing is when an animation gets played into here, it's going to go down into here and then get more animations here if we are jumping and other stuff. So we want to make sure we put the tag here and not here, because this is only our idle and walk. This is our idle, walk, run along with jumps. So we want to set the tag here. So what I'm going to call this is locomotion, or I'll call it local blend input. You know, something nice, something similar to what they have over in the game animation sample project. And what we're going to do now is, now that we've given it a tag, we're going to grab the node reference. So since we've called it local blend input, just look for a local blend and you'll see it pop up. So now we are able to grab the node context of this state machine and pass it into here. So anytime an animation is passed into here, we will be able to grab that data. However, we will still not be able to get the current blend stack anim asset, because again, that is specific to motion matching. So there's something a little bit different that we have to do for the local blend input. So what we want to do here is, from the local blend input, is we want to then drag off and do a convert to sequence player. And we want to grab the one under sequences right here, sequence player, because what we're trying to do is convert whatever we're getting into here into a sequence player node context. And where I'm getting sequence player from, if we open up, let's just say locomotion, right? And we go into our walk run, well, that's blend space player, that's different. Right here, you could see that this idle is a sequence player. However, a blend space player will also be a sequence player to a certain degree, because it has animation sequences being played out within that blend space. But this is what I was trying to show you. As you can see, this is a sequence player. So once we have that, let's go ahead and go back to the anim graph. So that's why we want to convert it to sequence player. But now off of the sequence player, we want to drag off and do get sequence right here, because what we're trying to do is get the current sequence that's being played in the sequence player. So that will be our anim asset, so that we can then plug that into here. But now we got to get the asset time. So off of the sequence player, what we want to do is get play rate right here. Get the play rate of the sequence player. So whatever animation is being played at that time, it will also grab the play rate of that sequence player playing that animation. So once you have that, you can go ahead and plug that into the anim asset time, and we have essentially set up what we needed for those. So now to pull over back the game animation sample project to show you is they are essentially doing the same thing here, but again, this is very specific to motion matching, or at least the node context within here. But for state machines, what you're going to want to do is do it this way, and you essentially get the same result. So now that we have that, we've essentially established a lot of the basic baselines of the orientation warping, to where now within your projects, you know, depending on whether you're using motion matching or state machine, you can now see how it functions like on a baseline attempt of how it warps your character and how it corrects itself and does other stuff. And lastly, with the target time, this is experimental, but what it's trying to do is it's trying to ensure that your root motion matches your capsule's motion at, you know, 0.8 seconds into the future. So basically, treat this as like, hey, we're making a prediction on how our character's rotation is going to be and where at with, you know, our character's capsule component 0.8 seconds into the future. So you can definitely set it short. It would probably be preferable to set this a little bit shorter. If I can click into that, there we go. You know, to maybe like 5 or something, you know, what it helps. But other than that, you know, that's basically what that's doing. And then the alpha, we're going to ignore that. We want that to be 1 because we want the magnitude to be at 1 for the higher strength, basically toggling it on, because as you set it to 0, it disables it. So now that we have that set up, the last thing that we need to do is we need to then set up reset root transform. And this is actually pretty important, and you don't necessarily need it for the baseline, but it's a good habit to have this in even as a starting orientation warping start. That way, when your character, when it goes back through and everything comes back through, that it resets your character's root transform and everything to make sure nothing is offset. This is primarily used with the anim offset, but it also helps again reset even in a component space of your character to make sure you're back in line with your capsule, everything's good and stuff like that. So now that we have that, when we hit play, once again, you can see that our character is pretty smooth. Even when we do rotations like this, you can see how the character swivels around on the spine bone now, you know, when using the orientation warping. So as you can see, we've essentially got like a pseudo 8-way locomotion just using orientation warping. So it is a pretty cool node. It's very awesome. I do like it. So to show you, a better example of what I got going on here. So if I pull the current project that I have open where I was playing around with a bunch of pose warping to get better with it, that you could see that I have similar stuff where, you know, we have our sequence player, we're getting the sequence, but then I'm like going through other pose warping stuff and how I'm training those together. And then within orientation warping, I have threshold set pretty high. I'm getting velocity in a different way. I also have the same direction. Everything's relatively the same. But then to check out a more notable, and I'll say, I'm not saying egregious as in bad, but more of an outstanding form of it. So when we take a look at the game animation sample project, you could see how they have that set up and how they're getting their alpha from here. And if you have seen my animation blueprint series for the game animation sample project, and I think one other where they were doing the enable animation warping, I have actually found this, which is funny. So when an animation sequence gets passed into here from the motion matching table, and it gets called into here, we're going to cast to that specific animation that is being played, and we're going to get the curve value from it. So if I go into blueprints and go into, I believe it's characters, UEF and mannequin, animations, and let's just say I do a run, right? And I'm gonna grab, let's just say I'm gonna do a backward run, so anything with a B, right? So let's get back left leg. You can see right here, the curve that they have is animation warping. So as you can see, the values, they're very small, but you'll see a 1 at the top and a 0. It's playing out onto a 1 until we actually do our turns or our pivots there, to where it then goes down to a 0 and then smoothens back out into a 1, because what it's doing is it's toggling off essentially orientation warping here and then picking it back up to correct us with our feet and leg placements when, you know, it gets re-enabled back to 1. So that's what it's doing there in those animations. So that's how it's toggling on and off of our orientation warping. Then as you can see here, I have a little bit more stuff set up. I'm working on a project that had, I'm doing away with a lot of stuff like in the event graph. So I'm doing it to where I'm getting values first, and then if we go back out into the event graph, I'm doing generate trajectory second, because I want to focus more on these rather than the velocities and stuff set within the essentials value, because I'm trying to delete and get rid of a bunch of stuff and utilize it with stuff that we're already calling that is just as useful than setting, I want to say, wouldn't say duplicate, but redundant values. So that's what I'm trying to do, is get rid of some redundancy here. So I'm actually able to get a little bit more out of this with using the trajectory for the for current velocity. But then you'll notice that I have minimum root motion speed thresholds. So when I go over this, when we look at it, so I believe it was like, no, it was in stride warping because I had to set it up for stride warping too. So when we look at it, how I'm doing a bunch of switches because I want to get different values for when we want to start or stop basically the threshold as far as, you know, or the orientation warping. And it's primarily to do with the crouching, because if I play this out, you'll notice how when we start, like everything looks good. But then when we do crouching, there's like weird little shifts that happen, but it's more apparent when you actually play out, you know, these values. Like if this was set to a 10 or something, it would be very apparent, like the jitteriness that you get from crouching. So that's why I had to set them to different switchings. And then we have locomotion delta thresholds, to where what I'm, this is pretty much like a bad thing of what I did. I actually need to fix this since I got a better understanding. It was just at the time of doing this, I didn't have a good understanding of it. Because what I was trying to see is if the default value is playing, then do this. If not, do this. But I gotta do other checks on it. So this is something I have to fix because it's not quite right. But yeah, this is pretty much other stuff that I have set up. So this is more of a more outstanding version of what you can do and accomplish with orientation warping. And then as you can see with the component space, we have warping space and we have the orientation warping, and you can see that it involves the offset root bone enabled because that's a data-driven console variable that epicgames has provided with gasp, that if this is false, we are going to make sure that everything is done within the component. But if this is true, we're going to focus on the root bone, in which case if we focus on the root bone, if I go back to the anim graph, we then play out the offset root bone here to where we get all these different methods here. And the offset root bone is something I'll go over in another video. But for the moment, like if you do want to play with the root motion warping space or root bone warp space or transform, you at least need to have the offset root bone set, and you can probably get by with just having a default offset root bone. Like if you just threw, where is it? If you just threw this into there and was like, all right, call it a day, and just did nothing else, but you might want to fix some stuff here, but interpolate is fine here. Because there's a lot of stuff I found out about this, to where one of the videos that I did with going over orientation or offset root bone within the game animation sample project, there was some things that I had misspoke on or misinterpreted or misunderstood. So I've done a lot of research since then and found a lot of interesting things about this, especially the max translation error. So there's a lot of things we got to go over for those, but that'll be something for another video. But as far as that goes, that is all for the orientation warping for the game animation sample project, or maybe your own project whatsoever. But I hope y'all did enjoy that. I hope it was educational, and I hope to see y'all use it in more of your projects. That is a very useful node that epicgames has provided us. So other than that, dev team, if you did enjoy the video, you know, check out my other videos and be on the lookout for future videos to come. I'll probably be kind of slacking on some videos just because, again, I've been pretty busy as this holiday season with doing other stuff, and a bunch of other things have come up. But I'll try to post more regularly, or try to get some more videos out, but I'll do more of the pose warping animation nodes and stuff like that, because I do believe these are very important. But other than that, dev team, y'all have a great rest of your day, and y'all take care.